This video discusses the importance of terminal value in a discounted cash flow analysis. It's an important but little understood calculation that frequently represents 50 to 70% of the total value of a long-term project. Because of this, if you're ever the buyer, seller, or analyst in the valuation of a long-term business, you need to understand what terminal value is and how it's calculated. Let's define it more precisely. Terminal value is the value of an ongoing project or business beyond the forecast period when annual cash flows can reasonably be estimated. Now, years ago, when present valuing a business or a long-term project, an analyst would typically make 15 to 20-year projections of future annual cash flows. But over the past few years, increasing economic volatility and uncertainty have caused these long-term projects to become, or projections, to become virtually worthless. In today's environment, a cash flow projection of 10 years or more wouldn't be taken seriously. Today, most annual cash flow projections seldom go beyond 5 to 7 years. But a business or a long-term project will generate cash flow and value well beyond that period. So how do you incorporate it into a discounted cash flow model? You do that by making a terminal value assumption. Now you start by making the assumption that cash flows will grow at some fixed average rate forever beyond the annual forecast period. Now that assumption of forever is really not a problem, since once you get beyond 20 years, the denominator of the discounted cash flow model becomes so large that the present value contribution of cash flows that far out are relatively insignificant. Now, as I said earlier, it's important to understand how terminal value is calculated because it represents such a large portion of the value of a long-term investment. Let's begin that explanation by first explaining how to calculate the value of an annuity. An annuity is a cash flow stream that grows at a fixed rate over time. Now, the present value in today's dollars of a perpetual annuity, that's one that goes on growing forever at a constant rate G, is shown here. Now, spend a moment studying this. It should look familiar. It's the discounted cash flow model where the annual cash flows increase at a fixed rate G each year. Now, it can be shown that this formula is mathematically equal to cash flow times 1 plus G divided by K minus G, where G is the assumed growth rate and K is the cost of capital. In other words, the present value at any point in time of a perpetuity growing thereafter at a constant rate, G, is equal to the cash flow in that year times 1 plus G over K minus G. Now that expression, 1 plus G over K minus G, is referred to as the cash flow multiplier. Now it's worth reiterating what we've said here. First, the cash flows from an ongoing project or business don't end at the end of a 5 or 7 year annual forecast horizon. The standard method for valuing such a business is to assume that beyond that horizon, which we refer to as time t, cash flows continue growing at a constant annual rate. Now, the present value at time t of the annual cash flows beyond that point is given by the expression of cash flow at time t times 1 plus G over K minus G. Again, that's the mathematical formula for a constant growth annuity. And 1 plus G over K minus G is referred to in valuation analysis as the cash flow multiplier. The total present value of the business in today's dollars equals the discounted value of the projected 5 or 7 years of annual cash flows plus the present value, the value today, of that terminal value at the end of the forecast horizon. Now, if this seems a little fuzzy to you, it might help to give a numerical example. Here's a cash flow projection for the next 5 years of an ongoing business. Let's assume that the cost of capital K is 12% and that beyond year 5, the cash flows are projected to grow at a 4% annual rate. Now, using our standard discounted cash flow model, the present value of the first 5 years cash flow is $361. Now, the terminal value in year 5 of all future cash flows beyond that point is given by our formula. Cash flow in year 5, which is 115, times our multiplier expression of 1 plus G over K minus G. Now, plugging in our assumed values for K and G gives a multiplier of 13 and a terminal value in year 5 of $1,495. That represents the discounted value in year 5 of all future cash flows beyond that date. Now, the present value of that today at time 0 is $848. That's what the 50-year terminal value is worth in today's dollars. So, the total present value of the business is equal to the sum of $361, that's the present value of the first 5 years cash flow, plus $848, the present value of the 5th year terminal value. Now, note, the terminal value calculation represents 70% of the total value of the business. And that's not atypical. And that's why it's really important for you to understand how it's calculated. Now, I'm going to describe some of the games investment bankers will play. And I know because I've done it myself. I want you to keep in mind that the market multiplier is definitionally the value of a constant growth annuity and is mathematically equal to 1 plus G over K minus G. There's no getting around that. It's a mathematical identity. Now, let's assume you're the seller of a business. The banker's buyer will tell you in an authoritative voice, the standard market multiplier for your type of business is 10. But you say, we've agreed that the projected long-term growth rate's 4%. And the buyer's required rate of return on this investment is 12%. Well, that would give a multiplier of 13. No, the banker's buyer will say, I assure you that 10 is the right number. Well, it's not. Having taken this class, you know either that they've substituted in a lower long-term growth rate or they've raised the required rate of return. There's no getting around that that's what's happening. Now, if you think about all this, you should see that a significant percentage, usually the majority, of the total present value of an ongoing business comes from only 3 numbers. The terminal year cash flow, which in our example was 115, the assumed long-term growth rate, G, and the cost of capital, K. Those 3 numbers really drive the present value calculation of an ongoing business. Now, there's no reason for the cost of capital to change from whatever its value is during the original 5 to 7 year annual forecast period. So keep your eye on the projected terminal year's cash flow at the final year of the forecast period, and the assumed long-term growth rate. Those are the numbers that really matter. Now, I hope you'll keep all this in mind if you're ever involved as a buyer or a seller or an analyst on a long-term capital project. Now, we'll put all this to use when we do evaluation of Bedford clinics later on in this module.